So let's move on to the another topic, that is graph theory basics. That is our third topic. Graph theory basics. What is graph theory? Graph theory is nothing but dealing with the graphs of different types. That's undirected or directed graphs. So we have many graphs, analytical graphs, so many. But we will be looking at only the basics part of graphs and the types of graphs we have. So let me define what is a graph. So graph is a pair of sets. G is equal to V of E, where V is the vertices and E is the edges. E is made up of pair of elements from V. So every edge is made up of two vertices. So that is the actual definition of a graph. So let me jot down that. So graph is a pair. Graph is a pair of sets. G is equal to vertices comma edges, where V is the set of vertices, E is a set of edges. So every E is made up of pairs of elements of V. So every edge is found between only two vertices. For example, and in social networking we will define the vertices as a node. This is known as vertices, and edge will be defined within a dash. This is edge. So let us take one example where we will be finding what is a vertex and what is an edge. So let me take a simple graph. Let me name as V1, V2, V3, V4 and V5. Let me take this point also, V6. So if in the question, if they explain something about graph theory, you have to write the definition as well as explain what are the vertices, what are the edges, and this cardinality and the degree of each edges, as well as the adjacent list. I will explain each and every step one by one. So let us take this example and let us find what are the vertices. So finding vertices are nothing but the nodes. So vertices V is equal to set of vertices are nothing but the dot representation, that is node representation. So here we have V1 as vertices 1, V2, V3, V4, V5 and V6 are the vertices of the given figure. So let us note down the edges also. So edges are nothing but the connection between two vertices. So edges is equal to, so let us draw all the edges. So edges V1 to V2, V1 comma V2, next one V1 comma V3, next V1 comma V6, next V6 comma V4, next V4 comma V5. 1 2 3 4 5. 1 2 3 4 5. So we got our 5 edges. So this is how we represent an vertices as well as the edge. So let us find the cardinality. Cardinality is nothing but the number of vertices it has. So cardinality is nothing but the number of vertices. So let us define cardinality as C. So we are finding a cardinality for the graph G. So let us define this graph as G. So cardinality of G is equal to, how many vertices we have? We have 6 vertices. So cardinality of a above graph is 6. So let us find the degree of each vertex. Degree is nothing but the number of edges it is connecting to. So degree degree of each vertex. So degree of each vertex is known as the number of connections. When it comes to directed graph, we will be taking a edge. We will be taking degree as of inbounding or outbounding edges. So let us consider for an undirected graph. So edge of each vertex is the number of connections between the vertex V. So let us note all the degree of each vertex in the above figure. So let me write all the vertices V1, V2, V3, V4, V5 and V6. We have 6 vertices. So degree DG of vertices of 5. So for V1, V2, V3, V4, V5, V6, I have to find all the vertices, all the degrees. So for V1, how many degrees are there? 1, 2, 3. So it is, so from vertex V, we have 3 edges. So number of edges is known as the degree. So V1, we has 3 degrees, and coming to V2, V2 has only 1 degree. So V1. So now for V3, V3 also have one edge. So for V4, V4 has 2 edges. V5 has single edge, and V6 has 2 edge. So this is the degree of each edge. Now let us find the adjacency matrix. I will write here itself. So adjacency matrix is nothing but matrix representation of the above graph. So we will be representing all the graphs within all the graphs in a row and column wise for our easy multiplication, for easy understanding. So let me take the matrix representation. So V1, V2, V3, V4, V5, V6. V1, V2, V3, V4, V5 and V6. So if there is a connection between any two vertices, make that cell as 1. If there is no edges, make that cell as 0. That is the representation of adjacency matrix. So let us take the V1 vertices. So V1 vertices has the edges between V2, V3 and V6. So in the cell column of V2, V3, V6, we have to place 1, and the remaining cells we have to place 0. So we have V2, V3, V6. So will be V2, V3 and V6. So remaining cells we have to place 0, as there are no edge between all those vertices. So coming to V2, so V2 has only one edge between V1. So V2 has one edge between V1 and remaining will be 0s. Coming to V3, V3 has only single edge, that is for V1, and remaining all will be 0s. For V4, so V4 has 2 edges for V5 as well as the V6. So V4 has V5 as well as the V6, and remaining all 0s. So coming to V5 has only single edge to V4. So V4 0 0 0 0 0. So for V6 we have V1 and V4. So V1 as well as V4 0 0 0 0. So this is the matrix representation of the above graph, and in some cases they might ask about the adjacency list also. Adjacency is nothing but the for vertex the number of edges connecting to. Let me write here itself. So adjacency list. So for V1, see how many edges are there. So it has 3 edges for which vertices? So vertices V2, V3 and V6. So we have to make note of all the edges between them. So V2, V3 and V6. And for V2 it has only V1. So for V3 it has only V1. So for V4 it has V6 as well as V5. We have to make note of the edges to which vertices it is connected to. So for V5 we have only V4. Let us check about the V6. So for V6 it is V1 as well as the V4. So this is the entire representation of graph theory basics. So in the so we have discussed graph theory definition is a set of pair of vertices between G as well as V comma E. So we will be representing every vertex as every vertex with a node in social engineering, social networking, and H with a dash notation. And for any given graph, we have to note if it is given for 5 marks or 3 marks, we have to make the list of each and every basic part from vertex, edges, cardinality, degree, adjacency list, as well as adjacency matrix. We have to make each and every answer markable. So that is the main base theory concepts. So let us also discuss about the types of graphs we have. So let us discuss types of graphs. So there are many graphs, but basically we'll be discussing only few graphs here, because as it is a graph theory basics itself. So we have to deal with the BFS as well as the DFS, but we will be not looking so depth in this module. So let me define the graphs. First one, null graph. So what is a null graph? A null graph is nothing but it does not have any edges, but it will have vertices between them. That is a null graph. A graph without any edges is called null graph. For example, this is a null graph. This is a null graph. So this is a null graph. It will be having only the vertices but not the edges. So it is known as the null graph. So let us move to the another graph, that is undirected graph. So what is undirected graph? Undirected graph is nothing but it doesn't have any direction, is known as undirected graph. The graph which doesn't have no directions is called undirected graph. So it doesn't have any directions. So so this is an undirected graph. This is an undirected graph. So this is an undirected graph. So you can draw graphs as per your requirement. So let us move to the another graph, that is directed graph. So directed graph is quite opposite for undirected graph. The graph which has directions is called directed graph. The graph which have directions is called directed graph. So this is an one directed graph, and this is one directed graph. So if we have the directions, is known as the directed graph. Let us move to the another graph, that is simple graph. A simple graph is nothing but the graph that has neither self loop nor parallel edges is called a simple graph. So it should not contain any self loops as well as the parallel edges, is known as the simple graph. A graph that has neither self loops nor parallel edges is called a simple graph. So example of simple graph is nothing but the triangle. So this is a simple graph. This might be a simple graph. It's also simple graph because it doesn't have any parallel edges as well as self loop. Self loops are nothing but the, if we have another loop like this, these are known as self loop. What are the parallel edges? So if we have another line, another what we'll call another edge, that is known as parallel edge. In simple graph, these two are negligible. So the graph which doesn't have self loop as well as the parallel edges are known as the simple graphs. Let us move to the another graph, that is connected graphs. So what is a connected graph? A graph is said to be connected if there exists at least one path between each pair of vertices. So if there is a connection, we have to reach each and every vertices. That is known as the connected graph. A graph, excuse me, a graph is said to be connected if they exist at least at least at least one path between each pair of vertices. It's called connected graph. So let us take one diagram, one rhombus. So in this graph, we can find that each and every vertex has at least one path to connect to the each vertex. So this is the one of the connected graph. Let us move to the another graph, that is the last final graph, disconnected graph. So disconnected graph is the opposite of connected graph. That is, the graph can be split into two or anything.